1.
Okay, guys, this is a review of problem number 8. So for 8, it tells us to consider two trig functions. It gives us f of x and g of x. First thing we should notice is that these two functions are almost identical, except for the fact that g of x has a translation, and it shows you minus pi over 2. So I noticed most of us answered D for this one, which is a shift to the right pi over 2 units. And I can see you have some knowledge of transformations when you say that, right? So important to eliminate A and C because they say that you're moving to the left. We all remember that if we have a minus, we're moving to the right. Okay. However, I did mention with this final, you want to be extra careful in what you're doing. So we want to at least check on answer choice B as well as answer choice D. So B says it moves to the right pi over 4 units. D says it moves to the right pi over 2 units. Now, at first glance, I can see how we would think pi over 2. The answer is that it actually moves it to the right pi over 4. All right. So for this, definitely put this in the y equals, and I would go to zoom trig. All right. When you put this in the y equals, all right, there's your original f of x. Okay. And when you graph g of x, it'll graph it right beside of it, and you would see that your first peak, and I understand it gives you decimals. So one good way of doing this would have been to use degree mode. All right, you can do zoom trig, use degree mode for your TI-83 calculator, and then these points are a little easier to plot, right? For example, this would say 45 degrees, comma 7 for your first function. Well, if you look at the peak for your second function, it's going to be at pi over 2, comma 7, which is pi over 4 units away. All right, in other words, 90, comma 7. So there's a difference of 45 degrees or pi over 4 units between these two peaks. Same as there's a difference of pi over 4 units or 45 degrees between these bottom peaks right there. You can see that's 3 pi over 4, so this will be pi. Okay, so that's if you would have gone the extra step to actually graph it. So again, all of that is doable. All of that is doable if you persevere. A little bit of quantitative knowledge behind this is if we, when we look at a horizontal shift, so I'm going to write this same function, and I'm just going to change one little thing. So if I have a 2 in front, that's what's causing me not to move pi over 2 units to the right. So I'm actually going to factor out that 2. And if I factor out a 2 from both terms, 2x and minus pi over 2, I'm left with x minus, if you divide pi over 2 by 2, you get pi over 4. All right? And you could double check that by redistributing your 2. And of course, we got the plus 4 there at the end. And you would see that those are now the same graph. All right? So again, if you want to think of redistributing, you could redistribute this 2. All right? 2 times x gives you 2x. 2 times negative pi over 4 gives you negative pi over 2. Okay? So you see everything checks out. With horizontal translations, again, it will move to the right if you have a minus. However, it only the amount is determined by a b value of 1. All right. If your b value is anything other than 1, you need to do like I did right here in my purple graph, and you need to factor out that b value so you can know the actual horizontal shift. This is actually called a phase shift when it comes to trigonometry. I hope this helped. If you have any questions, let me know.